Hello students, and welcome to another calculus video. In this lesson of 5.3, we're going to be looking at using the theorems that we've been taught so far to actually solve another problem. So let's get started. Alright, if you don't already have it nearby, make sure you do grab your calculator so that you can get through this problem properly. But let's kind of go through it real quick. We have a car company introduce a new car for which the number of cars sold, S, is modeled by this function. So this is the amount of cars that are being sold. What we want to do is find the value of S prime of 2.5. Using correct units, let's explain what this means in the context of our problem. What I want to do first is kind of just simplify S of t. And so go ahead and simplify that. And what I got is going to come out to be 300 5t plus 1 over t plus 2. So let's find the value of S prime of 2.5. Well, the way I'm going to do that is let's go ahead and graph this. And let's find the value of S prime of 2.5. All right, so I'm going to graph this. So that's going to be 300 times this fraction, which is going to be 5x plus 1. I'm not switching it to t once I put it in the calculator, and then x plus 2. All right, so we've got something going on right there. And what I want to find is S prime of 2.5. So I'm going to go menu, analyze graph, dy dx right there. And I'm going to, once I click it, you can see it blinking. And all I'm going to do is I'm going to type in 2.5. So 2.5, I'm going to hit enter. Okay. And you can kind of see we get this point right here. And let me drag it around. That's going to be the value. Let's kind of increase the float amount. And I get 133.3333. So we know that S prime of 2.5 equals 133.3333, and we want to use correct units. So this is cars sold, and what is the time? Because it's our X value over our Y value. So our X value is cars sold, and our Y value is in months. So cars sold per month. So let's say what is happening in the context of our problem. Our value is positive. S prime of 2.5 is greater than 0, so that means that the amount of cars being sold at 2.5 months is increasing. So when you're writing that statement, make sure that you specify that 2.5 is what you're talking about, and that since it's positive, since the derivative is positive, then that means that the amount of cars being sold is increasing at exactly 2.5 months. So now we want to come down here a little bit, and we want to find the average rate of change of cars sold over the first 12 months period. So the first 12 months is going to go from 0 to 12, and we want to find that average rate of change. After that, we'll look at our units and explain what this value means in the context of our problem. All right, so the average rate of change. So we want S of 0 minus S of 12 over 0 minus 12. All right, so S of 0, let me kind of go ahead and figure out what that is. So menu trace, graph trace 0, enter. And I'm getting 150 right here. Minus S of 12, so let's go ahead, menu trace, graph trace, and type in 12, and it jumps up there, 1307.143, so 1307.143 over 0 minus 12 is negative 12. All right, so type that into your calculator, and it should come out to be 96.429. Now, what are our units? So just like our last problems, we have cars sold in the numerator, and in the denominator, we have months, so cars sold per month. So what does this mean in the context of our problem? So for the first 12 months, from t equals 0 to t equals 12, the average amount of cars being sold per month is 96 cars being sold per month. And as I'm writing this, you just really want to notice that there's no way that you can answer this question with a fewer amount of words or less work being shown. This is exactly what you need to do to get straight to the point and accurately say, all right, what is the answer as accurately as possible with the right verbiage. All right, and in our last question here, is it possible that a value of C for 0 to 12 exists such that C prime of C is equal to the average rate of change? So again, we're looking here at C prime and average rate of change. Well, what should we be thinking about? Well, we should be thinking about the mean value theorem there. All right, so is the function continuous and is it differentiable? So let's kind of look here and let's find S prime of T. So we kind of simplified S earlier. So S prime of T, go ahead and take the derivative and you should get this. All right, and so for just like the original function S and its derivative S prime, you can look in that denominator and notice that there are going to be no values where the function is going to be undefined. At least they won't be undefined on the interval from 0 to 12. So S of T is continuous and it's differentiable on 0 to 12. So the mean value theorem must guarantee a value of C on that interval from 0 to 12 such that the derivative is equal to the average rate of change. All right, so since we have that spelled out, let's go ahead and find that value. Well, we've already done work to find that average rate of change from 0 to 12. So since we've already done that work, we can say from part B, S of 0 minus S of 12 over 0 minus 12 equals 96.429. Okay, so let's kind of use our calculator now and state where that is going to be. So I'm going to do what I did last time and I'm going to graph that derivative. We're going to go tab, and since my original function's in F5, let's pull up the derivative. Okay, so d dx of F5 of x. And let's graph that. And what I also want to do is I want to graph 96.429. So 96.429. We get that line right there. And if you zoom in a little bit, you can see here that they are crossing. So what we want is we want to be able to see where that intersection point is. So we're going to go menu, analyze graph, and we want to find that intersection. So the first graph is going to be F7 and the second graph is going to be F6. And you can go either direction, F6, F7, doesn't really matter. Calculator will figure it out. You just click and you drag and we get an intersection point. So 96.429 is the X value, or sorry, is the Y value, but we want that X value. And we're gonna go 3.2915. So T equals 3.2915. And we want to still specify, okay, what are the units? What are the units that time is measured in? And that is measured in months here. In order to use these, you notice that the arithmetic, the calculator work isn't too difficult. What is difficult about using these theorems is that you have to be very specific and you really need to show that you understand all the nuances related to those theorems. Of course, if you're not tracking everything that I put down here, please reach out to me so I can explain it further. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.